Good morning to one and all. My name is Dr. Jagadeesh, Assistant Professor, Department of UG, PG and Research in Mathematics, Government Science College, NT Road, Bangalore. The program for final year BSc, Bangalore City University. Today's session 15. The main topic is line and multiple integrals. Today we are discussing about the line integrals. Learning objectives. What is line integrals? Basic properties of line integrals and examples. Session outcomes. Students are able to understand the concepts of introduction and application of line integral, definition of line integral, basic properties of line integrals and examples. Prerequisites are the basic concepts of a line, that is, the line equations, basic concepts of differentiation, basic concepts of integration. Introduction. In this section, we define an integral that is similar to a single integral, except that instead of integrating over an interval a comma b, we integrate over a curve C. Such integrals are called line integrals. They were invented in the early 19th century to solve problems involving a fluid flow, forces, electricity and magnetism. Line integrals over a plane curve. A line integral is an integral of a function defined along a curve C, where C is continuous and smooth curve in a plane. That is integral over C f of x comma y with respect to x, or integral over C f of x comma y into dy and so on, are called line integrals of a function f of x comma y along the curve C. Basic properties of line integrals. The first property, integral over C k into f of x comma y into dx, where k is a constant. Therefore, we can write outside the integral k into integral over C f of x comma y into dx. Second property is integral over C f of x plus or minus g of x into dx. That means that integral over C sum or difference of two functions. We can write integral over C f of x into dx plus or minus integral over C g of x into dx. Third property, integration from a to b f of x comma y into dx equal to minus into integration from b to a f of x comma y into dx. In this third property, we can interchange upper and lower limit. The sign it changes either minus to plus or plus to minus. The fourth property, integration from a to b f of x comma y into dx plus g of x comma y into dy. That means that the function of two function with respect to x and with respect to y, we can split or we can write integration from a to b f of x comma y into dx plus integration from a to b g of x comma y into dy. So fifth property, integration from a to b f of x comma y into dx equal to integration from a to c f of x comma y into dx plus integration from c to b f of x comma y into dx, where c is in between a and b. First examples. The first problem, evaluate integral over c 5xy into dy dx plus y square into dy, where c is the curve in the xy plane, y is equal to 2x square from 0, 0 to 1, 2. In solution, given the curve y is equal to 2x square, you differentiate with respect to x, then y become dy by dx is equal to 2 constant, x square is 2x into 2 is 4x. Further, that implies dy is equal to cross multiply dx, the 4x into dx, That means that I'm changing the variable, so y to x, therefore the limit changes, that is x varies from 0 to 1. Therefore, given integral is integral over c 5 into xy into dx plus y square into dy. So equal to integration, I am changing single variable x, therefore x varies from 0 to 1, 5 into x, the y value is 2x square into dx plus y square is 2x square the whole square, the x whole square is missing, so 2x square the whole square, 4x into dx. So that is integration 0 to 1, the 5 2s are 10, x into x square is x cube plus here whole square is missing, just change it, that is 2x square whole square is, we can write 2 square is 4, 4 into 4 is 16, x square whole square is x power 4 into x is x power 5 into dx. So we can integrate this 10 constant, integration of x cube is x power 4 by 4 plus 16 constant, integration of x power 5 is x power 6 by 6, limit is 0 to 1, replace x by upper limit, that is 1, that is 10 by 4, 1 power 4 is 1 plus 16 by 6 into 1 power 6 is 1, lower limit is 0. Further we can write 10 by 4, we can write 5 by 2 plus 16 by 6 we can write 8 by 3. You take the common LCM 6, so that is 5 3 is 15 plus 8 2 is 16 plus 15 is 31 by 6 is the answer. Next example, evaluate integral over c 2x plus y into dx plus 3y plus x into dy along the line joining 0, 1 and 2, 5. In solution, the equation of the line joining 2 points, we require this formula. The equation of line joining 2 points x1, y1 and x2, y2 is given by, because here curve is not given, only line joining 2 points is given. By using that we can find the equation of a line joining 2 points, that is y minus y1 divided by y2 minus y1 is equal to x minus x1 by x2 minus x1. So y minus y1 is given points we can take as x1 y1 and x2 y2. Y minus 1 by 5 minus 1 is equal to x minus 0 by 2 minus 0. Then it is y minus 1 by 4 is equal to x by 2. 2 1s are 2 2s are cross multiply. Y minus 1 is equal to 2x, cross multiply. Y is equal to 2x plus 1. You differentiate with respect to x. Dy by dx equals to cross multiply dx. Then dy is equal to 2 into dx. So again in this problem I am changing the variable. So y to x, single variable. Therefore x varies from 0 to 2. Therefore, integral over c 2x plus y into dx plus 3y plus x into dy is equal to integration x varies from 0 to 2. 2x plus y is 2x plus 1 into dx plus 3 into y is 2x plus 1 plus x dx is 2 into dx. 0 integration 0 to 2. 2x plus 2x is 4x plus 1 into dx. 3 2s are 3 into 2 is 6 plus 1x is 7x plus 1 into 3 is 3 into 2 into dx. You take the dx common, integration from 0 to 2, the 4x, 7x into 2 is 14 plus 4 is 18x plus 3 into 2 is 6 plus 1 is 7 into dx. Integrate. So 18 constant, integration of x is x square by 2 plus integration of 7 is 7x. So limit is 0 to 2, replace x by upper limit. 2 square is 4, 4 by 2 is 4 by 2 is 2 into 18 is 36 plus 7 into 2 is 14, lower limit is 0, 36 plus 14 equal to 50 is the answer. Next example, evaluate integral over c x plus y into dx plus y minus x into dy along the curve x is equal to 2 into t square plus t plus 1, y is equal to t square plus 1 and t varies from 0 to 1. X is given, x is 2t square plus t plus 1. You differentiate both sides. So x become, so dx, 2t square become 40, t become 1. So 1 becomes 0. Therefore 40 plus 1 into dt. Similarly, y is t square plus 1. Then differentiate, y become dy, t square is 2t into dt, 1 becomes 0. So here is, I am changing the parametric equations x and y is parametric function of t. Therefore, I am changing both x and y to t. Therefore, t varies from 0 to 1. Therefore, integral over c x plus y into dx plus y minus x into dy, we can write integration over 0 to 1 plus 1, x is 2t square plus t plus 1. So y is equal to t square plus 1, dx is 4t plus 1 into dt plus y is t square plus 1 minus x, you multiply minus term, minus sign to this term, minus 2t square minus t plus minus 1 into dt, dy is 2t into dt. After simplification 0 to 1, so we can write 4t multiply this term. So that is 2t square plus t square is equal to 3t square into 4 is 12t square, and 1t into 4t is multiplication 40t square. 1 plus 1 is 2 into 40 is 80. Just you multiply 1, so that is 3t square plus t plus 2. Here is simplification, t square minus 2t square is equal to, we can write minus t square into 2t is minus 2 into t cube, plus 1 and minus 1 get cancelled, minus t into 2t is minus 2t square into d. After simplification, next step, we get integration 0 to 1, 10 into t cube plus 5 into t square plus 9t plus 2 into dt. We can integrate 10 constant, t cube is t power 4 by 4 plus 5 constant, t square integration is t cube by 3 plus 9 constant, integration of t is t square by 2 plus, so integral of constant is constant into function there, that is 2 into t, limit from 0 to 1. Replace, so t by upper limit is 1 and lower limit is 0. The upper limit value is t equals 1. 10 by 4 is equal to 5 by 2. T equals 1. 1 cube is 1. So that is 5 by 3. 1 into 5 by 3 is 5 by 3. T square is 1. So t is 1. 1 square is 1. 9 into 9 by 2 plus 2 into 1 is 2, lower limit is 0. Next you just simplification, 5 by 2 plus 9 by 2 is, that is common LCM is, add the numerator, 5 plus 9 is 14 by 2 is 7. So we can write 5 by 3 as it is, this 2 sum is 7 plus 2. Next step we can write 5 by 3, 7 plus 2 is 9. You take the LCM, so 9 3 is 20, LCM is 3. So 9 3 is 27, 27 plus 5 is 32 by 3 is the answer. And these two problems are an assignment for you peoples. And session summary, students are understand the concepts of definition of line integral and basic properties of a line integral and examples. And multiple choice, for the multiple choice questions. The first question, the value of integral over c 3x plus y into dx plus 2y minus x into dy along the curve y is equal to x square plus 1 from 0, 1 to 3, 10 is. You just work out, find out. After that you get any one of the answer. Just I am giving the key answer is to option is A, 213 by 2. And next second multiple choice question. For this question answer is option B, 34 by 3. And next question for option is C, 10 by 7. And for fourth question option is A, 3 by 2. And finally last question, so option is B, answer minus 24 pi. These are all the references. Thank you one and all for this session.